Hey everybody, so Ms. Reina here from the Academy for Health Science Professions. Let's continue now with Chapter 5. Chapter 5-1 deals with operations with polynomials. So here are some notes that if you can copy would be really beneficial to you because it shows you the properties, definitions, and some examples that we're going to be dealing with. All right, so when they ask you to simplify, it just means to rewrite an expression that contains powers, remove parentheses, any negative exponents, and do whatever operations it says, whether it is to add, subtract, multiply, divide, etc. So now we're going to be dealing with a polynomial. So let's see what a polynomial is. Well, first let's look at the properties of the exponents that we're going to be dealing with. So there are some properties we're going to have to follow to be able to do these type of questions. And some of these you already have been exposed to in Algebra 1. So we're just going to continue with that, have a quick review, and then move on with some operations with the polynomials. So here we go. So product of powers. So first of all, we're going to be looking at that property. So what does that mean? Well, product is always like the answer from a multiplication, right? And powers, well, you're dealing with some exponent and possibly another exponent. So what happens when I have x to the a power times x to the b power? Well, all you have to do is, since they have the same base, these are called bases, the x, you put the x, and all you do is add them. So think about it this way. When you multiply exponents, when you multiply, anything with a power, you add the powers, as long as the bases are the same number. So what does that mean? Well, look at this example. What is 3 squared times 3 to the 4th power? Well, since I'm multiplying some base that has an exponent, then I just have to add the little numbers at the top, the exponents. So you keep the base, which is a 3, and you end up with 2 plus 4, not times, so plus. So 2 plus 4, you get 6. So now, what if you have a division? A quotient is just some quantities that you divide, right? So when you end up dividing, let's say, x to the a power divided by x to the b power, what is the answer? Well, all you do is you keep your base, just like you kept your base over here. You keep the x, and all you do is subtract the little exponents, a minus b. So what does that look like as an example? Well, what if I have b to the 6th power divided by b to the 4th power? So when I have that kind of situation, you keep the base, the b, and you just subtract 6 minus 4. So when you multiply, you add. When you divide, you subtract. And so 6 minus 4, you get b2. So b squared. Well, what if I have a negative exponent? We really don't want to deal with negative exponents. And so what you do is you turn a negative exponent into a positive one. And it's a real simple step to do that. So what you do is, let's say I have x to the negative a power. All you need to do is move the x to the a, not the negative, x to the a power to the bottom of a ratio. So we're going to turn it into like a fraction, put it underneath the number 1, and now it's x to the a. So x to the negative a, you do the reciprocal, and it turns into 1 over x to the positive a. Well, what if you had 1 over x to the negative a, but the x to the negative a is like a quotient, right? And so this time, the same thing, reciprocal, you flip it. When you flip it to the top, it's like 1 times x to the a, and you remove the negative. So remember, anytime you switch, what changes is the negative sign, and then you either flip it to the top and remove the negative, or in this case, it's x to the negative a, bring it to the bottom, under the 1. So if I have 3 to the negative 5, what do? You bring it down and make it a positive 5, so 3 to the 5th power underneath the 1. If I have 1 over b to the negative 7, turn it positive, bring it up to the top, it's b to the 7. So now a power of a power. What if I have x to some power, that quantity to a power? Simple. You multiply a and b. So this would be x to the whatever these two numbers are, you just multiply them together. Look at the difference between these two. This is not a power to a power. This is a quantity times a quantity. Here, you've got this quantity to that power. In that case, you multiply. That's why over here you added. So what if I have 3 to the 3rd power to the 2nd power? Well, you just take the 3 times the 2, and it's to the 6th power. Then you have a power of a product. So what if you have two things, a product that you want to get from multiplying two things, right? You have x times y, but that is going to be raised to the a power. So you just distribute that a, make sure you multiply it. See, you don't see a little number 1, but both of these have a little number 1 right here. So this would be x to the 1st power times a and y to the 1st power times a. So 1 times a and 1 times a, you get x to the a, x to the a. So just think of distributing that a to each of these pieces and you're set. So an example, what if I had 2k to the 4th power? This is where some of you are going to make a mistake. You're going to say, oh, that's k to the 4th power and move on. But you forget that you have to give that 4th power also to the number 2. So this is 2 to the 4th power, k to the 4th power as well. And 2 to the 4th is just 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And then k to the 4th, you just leave it as such. Well, what if I have a quotient to a power? So the property is this one right here that we're going to look at. What if you have x over y, so like 1 over 5, x over 7, whatever, it's just two quantities, right? And you have those to a power. Just give the same thing. It's like distributing this power to this guy and this power to that one. One of the biggest mistakes you all make is you say, oh yeah, this is x to the a over, and you forget to give the power of the a to the letter y as well. So make sure you have x to the a, y to the a. And in this case, where y cannot be 0, obviously, right? Because remember, we don't divide, division by 0 is impossible at this point. So an example, what if I have x over y, I just left the letters like that, squared, same thing, x squared, y squared. You just distribute that to everything. Now, what if you have x over y to a negative number, right? So remember what we said, whenever you have a negative exponent, what was that magical thing that was happening? You kind of, flip it, right? So let's go ahead and do that. So if I have a over b to the negative 5th power, just flip them. It's like having b over a to the positive 5. So always think of when it's a negative exponent, flip it to the bottom, flip it to the top, and that turns it opposite. If it was negative, it'll turn it positive. And then, very important rule is the 0 power property, where you have this, any number, anything to the 0 power is always 1. So 100 to the 0 power, 1. 5 to the 0 power is 1. 10 to the 0 power is 1. 50 to the 0 power is 1. See, no matter what number I say is to the 0 power, that equals to 1. X to the 0 power is 1. The number 1, okay? So that's just something you have to memorize. So how do I figure out what the degree of a polynomial is? The degree of a monomial with the greatest degree. Whoa, so what does that mean? Okay, so we'll be seeing some examples in just a bit. So the degree is that little exponent, like right here, whichever has the highest degree, and we'll do some, we'll practice them right now, but I just wanted to give you the definition because it's hard to understand the degree of a monomial, and I'll explain what a monomial, binomial, trinomial, and a polynomial is in just a bit. All right, so what is a monomial? Okay, mono usually means 1. And so it's one term, right? So if you look at this here, I've got one term here, I've got one term here, a term and a term. The terms are divided by the by minus or subtract or add, okay? So this is a term, this is a term, this is a term, this is a term, etc. All right. So there are no powers of powers. Each base appears exactly once. So you only have the x ones, the y ones, etc. Each of those is just, those are the bases. All fractions are in the simplest form and there are no negative exponents. So if you have a monomial expression, it has to meet all of these properties. So no negative exponents. Each base is only once. You don't have like x, y, x, z, like all these things together. And of course you don't have powers to power. So it's, in other words, think of it just as a simplest, that you've already simplified everything as much as you can. So let's look at an example. I could ask you, well, determine if the expression is a polynomial and state the degree. All right, so let's look at this one right here. Is this a polynomial? Okay, so poly means many, so it's got many terms. So this has two terms. So yes, it's a polynomial, and I could also call it a binomial because it's got this piece and this piece. Remember, each piece, each term is divided by these signs. So here's one, then I have plus another one. If I had another plus, then it would be another one, etc. But is it a monomial? Remember, look at the definition of a monomial expression, right? And one of the stipulations is that all fractions are in simplest form. So here, when you have this fraction, that's not simplified because I don't even know what these terms are or what they stand for. So this would not be considered a monomial. Let's look at example number 2. Is it a polynomial? Yes, it's a polynomial. Why? Because I've got this piece and this piece. So it's not a monomial. It's not a binomial, which would be 2. A like a tricycle that has 3 wheels, a trinomial would be 3 pieces. This has 2 pieces, so it is a binomial, so therefore it's a polynomial. And then we have, what is the degree? Okay, so the degree, since these have multiple exponents in them, what you do is you check which one is the highest. So let's look over here. So 4, exponent 4 and exponent 3, you add them. So the degree of this term right here is 7 because 4 plus 3 is 7. So it is a polynomial. So the degree is 7. So are all of these monomials? Well, let's see. Each of these terms, if you look at it, it's to the simplest form. None of these are repeating. There's no fraction. So yes, this is considered a polynomial because you've got this piece, that piece. So each of these monomial pieces would be like a binomial. It's 2 of them, so it's a polynomial. And what's the degree? Well, the degree of this one is 5 plus 1, so that would be 6. The degree of this one is 4 plus 3, which would be 7. So the degree is 7, so that's the largest one. And don't forget, so when you're doing these, don't count this like, oh, there's nothing here, so I'm going to count 0. No, remember, if it was y to the 0 power, this would be a 1, so it would wipe out. So this is actually the number 1 up here, so it's 5 plus 1 is 6. So be careful when you're adding up the degrees. You have to add the exponent, even if there isn't one, it's an imaginary 1 in its place. So now let's look at your packet. So in your packet, you'll see that it's section 5.1, operations with polynomial examples. And here you have the notes that I just gave you that I went over are right here. So just kind of go over them one more time to make sure that you understand the ideas. Of course, what is a monomial expression? And then here we have some practice problems so that you can try. They actually write it out. So just to show to you what it means to be like b to the 4th power. Well, it's like writing b times b times b times b. Remember, exponents are just shortcuts of multiplication. And so if they ask you to simplify it, you can start canceling stuff out. So on the bottom, you have 2 A's, it looks like here, so they cancel. You have 1 left over, etc. So that's the long way of doing it. But if you follow the rules with the properties that I shared with you, then this should go and be a little bit faster for you to do. So notice how you're going to be simplifying expressions, and that way it's just working with these like a power to a power and so on and so forth. So in the notes, you also have how are you going to simplify these expressions, and it's basically very simple. When it's a subtraction, remember, you got to distribute that negative. You got to give it to every piece that you have over here. And then once you do that, then you can do the operations. And you have to always match the bases. So if you have a to the 3rd power, that can only be subtracted from a to the 3rd power. You can't subtract like this piece from the 2 or the 3a, etc. So we'll be doing that. So, and if you notice, they give you an example where they line them up to make it easier for you. So if that makes it easy for you, then do it this way. Line them all up so that you can see the x squared, the x, and then the numbers. And now you can do the operations, whether it's subtract, add, etc. So practice, there are some more examples here. Practice with these. This is distribution. Don't forget to distribute the negative y to every piece. And we'll do some problems right now just to keep reminding you of that. All right, so let's look at the study guide. You've got all the power properties and so on that I just shared with you in the notes. So now you get to practice with them. Look at these examples because they give you a good idea of some of the steps that you have to follow. So just kind of follow along. What I would do is try to do it on your own and then see if your steps match the steps that they listed here. So let me go ahead and here are some of the exercises. So let me go ahead and do a couple of these for you. I'll probably do one with multiplication and then with one of them with the division. So let's get started here. Let's do a power to a power. So like number 3. Remember the rule was if you have something a to the 4th power to the 5th power, you just multiply the 4 times the 5, which in this case then gives you a to the 20th power. If you have something like this right here, well, notice it's to the -1. Since it's already a fraction, all I got to do is flip these. So this turns into a to the -3, b squared on top of the one that was on top. Now it comes to the bottom, a squared and with the b. So now that I have them in the correct order, I can start doing things such as simplifying it even more. So to continue simplifying, I look at the terms that and so here I see that the a's are the same. So remember, when you're dividing, you just subtract the little numbers, right? So you subtract the exponent, -3 minus 2. So that gives me a. And if I have -3 minus 2, that is equal to -5. So this turns into a -5. And then I have the b, 2 minus 1, which is just 1. So I'm kind of almost finished, but I see a problem. I have a negative exponent. And remember, we always try to turn our negative exponents into positive. Well, that's an easy fix. So what I do now is, let me erase the work that I did here, and I'm going to write the answer there. So remember, we want to turn it positive, and so what do? Just bring it to the bottom, a to the 5th. Since there's already a b there, I don't need to put it under a 1. So my final answer is b to the 1st power. You don't have to write the little 1, and then you just over a to the 5th power, and you're done. So let's continue looking at some more problems. So here we go still with looking at the polynomials and then see multiply. Remember we did the FOIL, F-O-I-L, the FOIL method to solve these. So we can do that if we see some, but it looks like, let me go ahead and simplify one of these for you. So let's do question number 1 because I do see a subtraction. So you're supposed to take all of these terms and subtract all of these terms, but you got to be careful because watch, if I give this negative to the positive, it becomes a negative. If I give this negative to here, it becomes a negative, but check it out. If I distribute this negative to this negative, it's actually turns it into, I'm going to add. So let's start the process. The ones that match, 6x minus 4x, that should equal to 2x with squared, sorry. So it was 6x squared minus 4x squared. And then I have this term and then this term that match because those are both x's. So what I would recommend, if you have colored pens, you can do what I'm doing, or just on one underline, the other one circle, the other one maybe put a square, the ones that match. That makes it a lot easier for you to be able to do the problem. So let's continue. I have -3x minus an x, so that is -4x because they're both, you have a -3x and then minus x, you add them because they're the same sign. And then the last terms, I'm going to do them with a box. So I have a +2 and a +3. Remember, this was negative, but I'm supposed to subtract a negative. Subtracting a negative is actually adding, right? So then I end up with 2 + 3 is 5 in that case. So if we continue, let's try to do one of these problems with finding the product. So let me go ahead and just do the first one. So now if I have something outside of the parentheses, I always have to distribute inside. So let's multiply those two out. Let me just get rid of that so we can have more room. Okay, so then 2x times 3x squared is 6x to the, now remember, I'm multiplying x to the first power times x to the second power. When you multiply exponents, you add them. So 1 plus 2 is 3. And then now I'm multiplying 2x times negative 5. You just multiply the numbers, negative 10. And since there's no x there, you just keep it there. And so that's pretty much what you do with that one. Let me continue. So you'll have some more questions to work on. So it says simplify. Let me work number 7 for you. So 7, it's just a simple multiply this stuff with this stuff. And so let's go through the process. So we start. First, there's a number, 4 times negative 5. That's just negative 20. So I write it down. Then d squared times d. This is d to the first power. So remember, when you're multiplying the same basis, add the exponents. So this would be d to the third power. Then t to the fifth times times t to the negative 3. So 5, remember, you can just add them. In this case, you subtract because it's 5 minus 3, so you have 2. And then v to the negative 4 times v to the negative 1. Since you're multiplying them, you add them. So that would be v negative 4 plus a negative 1. You add them because they're both the same sign. You have that. So this is a negative right here. So I'm closer, but now anything negative, I have to move to the bottom. So my final answer would be negative 20. D to the third power is fine. T squared is fine. But my v to the negative 5 would be v to the positive 5 if I move it down. And now I have my final answer. So in the next sections, you're expected to continue doing the same thing. It's just, let me do maybe one more with division to help you with that. So let's try something like number 16. Remember, since 16, and sorry, let me fix it here. Number 16 wants you to, take, okay, first it's a quotient, so it's a division to the negative 2. I could already fix the negative 2 really easy. Remember, anytime you have like a fraction to a negative power, flip them and then make it positive power, right? So in this case, it would be negative x squared y to the 5th on top. And on the bottom, you would have the 2x to the 3rd y squared at the bottom. And so now we could actually distribute that square to both the top and the bottom pieces. So let's not forget, it has to come to this, and then to this one, and to this, and don't forget to the 2 also. All right, so we have negative x to the 4th power, y to the 10th power. Why? Because to a power you multiply, so 2 times 2 is 4, 5 times 2 is 10. Then at the bottom, we have 2 squared. Don't forget, see, because this is 2 to the 1st power. 1 times 2 is 2. X to the 6th and y to the 4th power. So I'm getting closer to getting some kind of answer, right? So I already distributed everything that I have in there. So let's go ahead and continue with that. And so let's go ahead and, whoops, I just realized I made a mistake. See, isn't there a negative 1 here in the front because there's a negative sign? So I should have had negative 1 squared also, which negative 1 squared turns into positive 1, so this disappears. So that's what I should actually have. Okay, so now we can go ahead and start simplifying. So let's see if there's anything I can go ahead and take care of here. So first of all, this is 4 right at the bottom. So I'm just going to write the 4. That negative 1 squared, disappeared because negative 1 became a positive 1. But now the x's. So I have an x. And how do you take care of quotients? You take this number minus this number. So I'll just do it. 4 minus 6 is 2, negative 2. And so that's x to the negative 2 power. And here the y's, you take this minus that. So it's 10 minus 4. That equals to 6. So this was negative 2. So this is y to the 6th. So I'm almost done. This x does not belong up here because it's negative. So let's just bring it down here, x squared, make it positive. And now I'm kind of done. So now let's just write it nice and pretty. This is y to the 6th over 4x to the 2nd power. And I'm finished with that question.